Hi Math 2 students, welcome to Edpuzzle 2.4. So let's go ahead and get started. For number 1, it says use the area model to represent each of the following, then multiply and combine like terms. So we're going to use that area model that we learned. Draw on our boxes. Notice how it's x plus 7 squared, which is the same as x plus 7 times x plus 7, so that's why I'm writing it twice. We'll go ahead and we multiply, we get x squared, 7x, and 49. Then we're going to go ahead and combine like terms, so we get x squared plus 14x plus 49. All right, let's try the next one. We'll set up our area model, draw on our boxes. And again, x plus 10 is the same as x plus 10 squared is x plus 10 times x plus 10. So we write it out like this. We multiply, we get x squared, 10x, and 100. And we combine like terms, we get x squared plus 20x plus 100. So 2 says, when you square the binomial, what do you notice about b and c in the result, x squared plus bx plus c? Well, this b value here always ends up being 2 times this number, right? Here it was 7 and we got 14. Here it was 10 and we got 20. So we could say that b is equal to 2 times a. And then if we look at c, it always ends up being that value squared. So we could say that c is equal to a squared, right? Because we get 7 squared, 49, 10 squared, 100. All right. Next, let's try 3. Use an area model to represent each of the following, multiply and combine like terms. So we're doing the same thing we just did. We set up our area model, x minus 8, x minus 8, x squared, minus 8x, and then we get a positive 64. So we get x squared minus 16x plus 64. Next for b, we're going to multiply these out. We get x minus 11, we get x squared, minus 11x plus 121. We're going to go ahead and combine like terms. We get x squared minus 22x plus 121. So for 4, it says when you square the binomial x minus a squared, what do you notice about b and c as a result? Well, b is going to equal that negative a times 2, right? So this here was negative 8 times 2 gives us negative 16. Negative 11 times 2 gives us negative 22. So b equals negative a times 2. And c, again, just equals a squared, right? 8 squared is 64. 11 squared is 121. So you get a squared. So for 6, it says, find the missing value that would make the trinomial a perfect square trinomial. All right? So what they mean by perfect squares, these things are called perfect squares. Okay? And that's because their factors can be written in this form where we get x plus something or x minus something, and then that quantity squared. So how we do this is we know that this value is always 2 times a, right? So if 6 is 2 times a, well, then that means that a is 3. All right? And we know that that third term is always your a squared. So we get 9. Here, we know that this term is always your a squared. So if our a squared is 100, that means that our a is 10. And since there's a minus sign, that tells us it's going to be a minus. And the middle term is always 2 times a, so it's going to be 20. Then we try c. Again, this middle term is always 2 times your a value. So in this case, it's going to be x minus 9. squared. So then our missing term is going to be 81. So it's always our a squared, right? This is 2a. This is a squared. Next, we can see that our a squared is going to equal 144. So the square root of 144 is 12. That tells us that our a is 12, right? And then our 2 times a is going to give us 24. Here we know that our 2a is 5. 5 divided by 2 is 2.5, or you could just leave it as 5 over 2. And then we know that this, so it's not here. Actually, I should write it like this. So we'd have x plus 5 over 2 squared. And then to get our value, that's always a squared, which would give us 25 over 4. Hopefully you're kind of recognizing a pattern. Essentially, it just follows this pattern of x squared plus 2a, or I should say it's plus or minus 2a, plus a squared. You know, if it's if there's a subtraction sign in the middle, it's going to look like this one. If there's a plus sign, it's going to look like that one. All right. So next it says, rewrite each of the following as a perfect square. So let's figure out what our a term is going to be. You can find it 2 ways, right? You could take the square root of this guy, or you could divide this guy by 2. And we know that our middle term is going to be a minus because there's a minus here. We end up with 4. So you would write it like that. This one, we know it's going to be an x plus because we've got a plus sign. And then to find our a, we could divide that by 2, which would give us 13. Or we could take the square root of 169, which also gives us 13. Then here, we know it's going to be a minus because there's a minus sign here. Then again, we could divide, so we can get 7 over 2, or we could take the square root of that, which also gives us 7 over 2. And that would be our answer. So hopefully you're kind of at this point picking up on the pattern, all right? So for these, what I'm going to do is I'm going to show you the problem, and then I want you to try these on your own to find the missing part, all right? So looking at this, we have to figure out the missing part. It would be 18 divided by 2. That's going to give us our 9. So then our missing part would be 81, because that's our a squared. We know it's going to be x minus because we got a minus sign. If this is our 2a, that means that a is going to be 5. You square it. Our a squared is going to be 25. We got our minus sign. So we've got x minus something squared. 26 divided by 2 is 13. 13 squared is 169. We write it as a perfect square. We get x plus. Our a is going to be 16 divided by 2, which is 8. So our missing part is going to be 64. If we write this as a perfect square, we get x minus. And 18 divided by 2 is going to give us 9. And we get 81. We've got our last one. This is going to be another x minus. 24 divided by 2 is 12.